4 cards are of the same color. So that means either I need to choose 4 cards which are red, or I need to choose 4 cards which are black. And whenever we have anything, object which is repeated n number of times, we need to divide the factorial here. So we know here S is repeated 4 times, so divided by 4 factorial. 7C4 is same as 7C3. So therefore this can also be written as 7 into 6 into 5 divided by 3 into 2 into 1, and 4C1 is 4. Hello everyone, a warm welcome to one and all. This is Vidhyaashram ma'am, Vidhyaashram School of Excellence, Mysuru. So in our previous session, we have studied about the combination. So let us take few more problems on combination. First question, what is the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many of these 4 cards are of the same suit, 4 cards belong to the 4 different suits, are face cards, 2 red cards and 2 are black card, 4 cards are of the same color. So let us find the solution of each sub-question one by one. Now, first let us find out the number of ways of choosing 4 cards where 4 cards are of the same suit. So that means I need to choose 4 cards which are of the same suit. So I know that out of 52 cards, there is a subdivision of each cards which contain hearts, diamond, so spade, and so each cards contain 13 cards of the same shape here. So all of them in total, so it is 52. And now among them, these 2 are of red colors and these 2 are of black colors. So now the first thing is we need to select 4 cards of the same suit. So what is the number of combination of selecting 4 cards of the same suit? So that means either I should select 4 cards from heart or 4 cards from diamond or other 2. So let us see the combination. So therefore here the number of ways, first problem, is equal to 13C4. Or, so when I say or, it is nothing but plus. So therefore it is plus 13C4 plus 13C4 plus 13C4. So that means out of 13 hearts, I need to choose 4 hearts, or out of 13 diamonds, I need to choose any 4 diamonds which are of the same suit. Similarly, the other 2. So I can choose any one suit where it contains the 4 cards of the same suit. So that's why I'm using 13C4 plus 13C4 plus 13C4 plus 13C4. So here it is 4 times 13C4. So which can be written as 4 into, so 13C4 is 13 into 12 into 11 into 10 whole divided by 4 into 3 into 2 into 1. So evaluating this, you will get 2860 after simplification. So the number of ways where we can select all the 4 cards of the same suit is 2860. The next sub question is we need to choose 4 cards belong to 4 different suits. That means 1 from each card or each suit. So therefore here the number of ways is equal to 13C1, and when I say and, it is multiplication. So again 13C1 and 13C1 and 13C1. So that means I need to select 1 card from each suit. So there will be 4 cards which is 4 different suit. So therefore here we have 13C1, 13C1, 13C1 into 13C1. We know that NC1 is equal to N. So therefore here 13 into 13 into 13 into 13, that is 13 power 4, whose value is 28,561. The next case is we need to find out the face cards. That means the card which contains faces. So we know that the king, queen and jack contain face cards. So among those face cards, I need to select any 4 cards. So there are only 12 cards because from each suit we have 1 king, 1 queen and 1 jack. So therefore there will be 12 face cards. Out of that we need to choose 4 cards. So therefore here the number of ways is equal to 12C4. So which is 12 into 11 into 10 into 9 whole divided by 4 into 3 into 2 into 1. So we'll get the value 495. Next question. So we need to select 4 cards from 52 cards where 2 are red and 2 are black. So that means how many reds we have? We have 26 reds and black 26. So that means we need to choose 2 red cards and 2 black cards. So therefore, here the number of ways is equal to 26C2 and 26C2. That is, out of 26 red cards, 2 red cards must be chosen, and out of 26 black cards, 2 red cards must be chosen here. So again, this is 26C2 can be written as 26 into 25 divided by 2 into 1 into 26 into 25 divided by 2 into 1. So we will get the value of 105,625. So that is 1,05,625 ways of selecting 2 red cards and 2 black cards out of 52 cards. Next, the last sub question. 4 cards are of the same color. So that means either I need to choose 4 cards which are red or I need to choose 4 cards which are black. So therefore, here the number of ways is equal to 26C4 or, so it is plus 26C4. So here it becomes 26 into 25 into 24 into 23 whole divided by 4 into 2, 3 into 1. Similarly, plus 26 into 25 into 24 into 23 divided by 4 into 3 into 2 into 1. So evaluating this, we'll get the value 29,900. So this is how we will choose the given number of cards. Next question. In how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl? If each cricket team of 11 must include exactly 4 bowlers. Now, so total number of players is equal to 17. So number of bowlers among them is 5. Now remaining players is equal to 12. The condition is that we need to choose a cricket of 11. Out of them, 4 must be bowlers. So out of 5 bowlers, 4 bowlers has to be in the team. Then how many are remaining in the team? So that is 7. And these 7 player has to be selected from the remaining player. So therefore, the number of ways of selecting a team where 4 are bowlers is 5C4 into 12C7. So 5C4 can also be written as 5C1 because we know this NCA is equal to NCB. So here N is equal to A plus B. So this can take a place. So 4 plus 1 is equal to 5. So using the properties of combination, we can write this. And similarly, we can also write 12C7 as 12C5. So this helps us simplifying the smaller value. We know that NC1 is N. So this is 5. And here if we solve this, 12 into 11 into 10 into 9 into 8 whole divided by 5 into 4 into 3 into 2 into 1. So here we can see 5 2s are 10, 4 3s are 12. So we have 5 into 11 into 9 into 8. So the value will be equal to 3,960. Next question. A bag contains 5 black and 6 red balls. Determine the number of ways which 2 black and 3 red balls can be selected. So we have 5 black balls, we need to select 2 black, and we have 6 red balls, we need to select 3 red balls. And since the combination in the form of an AND, the number of ways is equal to 5C2 into 6C3. So 5C2 is 5 into 4 divided by 2 into 1. 6C3 is 6 into 5 into 4 divided by 3 into 2 into 1. So 2 ones are 2 twos are 5 twos are 10 into 3 twos are 6, 6 is 20. So 20 into 10 is 200. Next question. A committee of 3 persons is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? How many of these committees should consist of 1 man and 2 women? So a committee of 3 persons is to be constituted from 2 men and 3 women. So in how many ways this can be done? So now here 2 and 3 is equal to 5. So the total number of person here is 5. So total is equal to 5 and I need to form a committee of 3 persons. They may be men or they may be women. So therefore, for the first condition, the number of ways is equal to 5C3. So which is 5 into 4 into 3 divided by 3 into 2 into 1. So it gets cancels. So it is 10 ways. So there are 10 ways of selecting 3 persons in a committee which contains 2 men and 3 women. Now the second condition is here. Let this be A and let this be B. They're asking us in how many ways can this be done? How many of these committees should consist of 1 man and 2 women? So here obviously it is a 3 persons and now out of 2 men I should consider 1 man and out of 3 women I should consider 2 women. So here the number of ways is equal to 2C1 into 3C2. So which is 2 into 3 which is 6 ways. So that means a committee compulsory consists of 1 man and 2 women. So that can happen in 6 ways. The next question. In how many ways can be the letters of the word assassination be arranged so that all the S are together? So this is a problem on a permutation. So because it's an arrangement consists of a word here. So we need to tie all S as one unit here. So let us count the number of letters in the word assassination. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means total number of permutation is equal to 12 factorial. And whenever we have anything, object which is repeated n number of times, we need to divide the factorial here. So we know here S is repeated 4 times. So divided by 4 factorial. And S 4 times we have, A we have 2 times, 1, 2. So therefore divided by 2 factorial. Next I, 1, 2. I is repeated 2 times. So divided by 2 factorial. Next N, 2 times. Then we have T and O which is only repeated once. So again divided by 2 factorial. So this is the total number of permutation. But my question is I need to arrange the letters in such a way that all S are together. So now there are 12 letters. Among them all S must be together. So let me tie all S as one single unit. So this is 1. Now 4 letters are used in this unit. So how many letters are remaining? 8 letters are remaining. So 1 plus 8 is equal to 9. That means there are 9 objects which has to be rearranged to form a new arrangement. So therefore here the number of ways is equal to 9 factorial. And among the remaining 8 objects, we have A, I, N repeated twice. So therefore this is divided by 2 factorial into 2 factorial into 2 factorial. Now let us come back to the unit containing S. Now here if we rearrange S if we interchange them, it's the same arrangement. So therefore, there will be only one arrangement here. So therefore, this is only into 1. So the value is 9 factorial divided by 2 factorial, 2 factorial, 2 factorial. Now suppose if they ask us to find the number of arrangement where the s are not together. So that means we need to subtract these two equations. Total number of ways by number of ways where s are together. Next question. A group consists of 4 girls and 7 boys. In how many ways can a team of 5 members selected if the team has no girl? Second one, at least 3 girls. Third one, at least 1 boy and 1 girl. So first let me calculate the number of combinations for no girl. So here we have 7 boys and 4 girls. Now I need to form a team where there are no girls. So that means I need to select 5 members which are boys only. So here I need to select 5 boys and no girls. So therefore, number of ways is equal to 7C5 into 4C0. So therefore, here 7C5 can also be written as 7C2 because 5 plus 2 is 7. 4C0 is nothing but 1. So 7 into 6 divided by 2 into 1. 2 3s are, so 21 ways. The next question is at least 3 girls. So that means minimum 3 girls must be there. So therefore, what are the combination we can choose? So we have boys and girls here. So 7 boys and 4 girls. Now we need to select at least 3 girls. So we need to form a team of 5. But among them, we need to choose at least 3. If I choose 3 girls, then the remaining has to be boys. Now, if girls is 4, then boys has to be 1. So here, the number of combination or number of ways is equal to 7C2 into 4C3 or means plus 7C1 into 4C4. So here, the combination goes in such a way that if we choose 3 girls, then there should be 2 boys. Suppose if we choose 4 girls, then it has to be 1 boy. So therefore, any of the combination is valid. So that's why we are using OR here. So now let's evaluate this. So here 7C2, 7 into 6 divided by 2 into 1. 4C3 can also be written as 4 because 4C1 and 4C3 are same. And we know that NC1 or NCN minus 1 is N only. So therefore it is 4. And here 7C1 is 7, 4C4 is 1. So here if you evaluate this, so 21 into 4 is 84 plus 7. So that is equal to 91 ways. The next question is we need to choose at least 1 boy and 1 girl. Now let's try the combination here. So number of boys is 7, number of girls is 4. So now if I choose 1 boy, then there must be 4 girls. If I choose 2 boys, then there must be 3 girls. If I choose 3 boys, then there must be 2 girls, and if I choose 4 boys, then there is at least 1 girl. So these are the combination because we need at least 1 boy or at least 1 girl. So here the number of ways is equal to, I can choose as 7C1 into 4C4 or I can choose 7C2 into 4C3 or I can choose as 7C3 into 4C2 or I can choose 7C4 into 4C1. So these are the combination. Now let us evaluate this. So 7C1 is 7, 4C4 is 1. Next 7C2. So we have already calculated 7C2 which gives us 21 and 4C3 is nothing but 4 itself. Again 7C3 here. 7C3 is 7 into 6 into 5 divided by 3 into 2 into 1 into 4C2 is 4 into 3 by 2 into 1. Next we have 7C4. 7C4 is same as 7C3. So therefore this can also be written as 7 into 6 into 5 divided by 3 into 2 into 1. And 4C1 is 4. So here if we evaluate this, 3 2s are 6, 6, 3 2s are 6, 6, 2 1s are 2 2s are. So let us evaluate this. We have 7 plus 84 plus. So we have 7 into 5 into 2 into 3. We'll get this as 210. So next we have 7 into 5 into 4, which is 140. So adding all these values, so the total value we'll get is 441 ways. So this is how we'll solve the problems using permutations and combination. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.